Alright, in this video here, I'm going to use BGP's AS path and MED attributes to influence traffic from one AS to another. So here's the network diagram that I'll be working with. So basically router 1 and router 2 is in its own AS 65100, while router 3, 4, and 5 is in AS 65200. And all of the loopback addresses are advertised into the BGP network for that router, and also the connected networks are advertised as well. So let's take a look here at router 1 to see what it looks like. Show one pipe again, router. So for router 1, it has a neighbor to R3 and also R2 right here, and the loopback network and the directly connected network between R1 and R2 is advertised here. And then for router 2, pretty much the same. Right here, so router 2 has a neighbor to R4 on AS 65200, and it has an IBGP neighbor to R1. And the loopback address is advertised, and then the local network is also advertised. So you can see how that works there. And then R3, let's take a look at R3. We can see that, let's run pipe again, router. Router 3 has a neighbor to R1. It also has a neighbor to R4 and R5 being in its IBGP neighbor. And then R3 has its loopback address, and the two locally connected networks to R4 and R5 is also advertised in there. And similarly, same for R4. R4 here, you have neighbors to R3 and R4 has neighbors to R3 and R2, and then also R5. Alright, so basically that's how that works. Let's take a look at router 1 here and see what kind of routes we're seeing. What kind of BGP routes. So R1 is learning routes in AS 65200, right? In AS 65200, such as the loopback 3, loopback 4, and loopback 5.5.5, and it's learning that through the best path of R3. I mean, that's the way it should work, right? Because R1 and R3 is the eBGP neighbors, so eBGP is the preferred path over IBGP, right? So this is the preferred path for R1 to get to the networks in 65200. For example, R1 is learning loopback of 5.5.5.5 through R3. So if I do a trace route of 5.5.5.5, you can see that it goes through R3 and then R5. So that's the preferred route. But now, let's say we want to influence this path. We don't want R1 to go through R3 to get to networks in the 65200 AS. We want R1 to go through the path of R2 and R4, right? So to do that, I'm going to use AS path. Right now, R1 is learning our routes in 65200 with this AS path, the AS path of 65200. So if I somehow tell R1 that it takes a longer path to get to R3, then R1 is going to choose R2 and R4's link to get to AS 6500. So we can do that by using the AS attribute. And to do that, we want to configure that on router 3. Router 3 is going to tell R1 in order to get to networks in 65200, I'm advertising my path to you with a few of the AS path numbers here. So that will force R1 to choose R2 to R4 to get to the AS 65200. So we're going to do that by configuring R3. So how do we do the AS path? So we say configure T. We need to create a route map. AS path, we'll call that AS path. All right, and then we're going to say set AS path prepend, and then we'll just give it an AS number. So right now, R1 is learning all of the networks in 65200 through the AS path of 65200, just one AS path away. But if we tell, if we configure R3 to tell R1 that it takes a few AS paths to get to those networks, it's not going to prefer that route. So that's why we need to say AS path prepend, let's say 65200. Let's add another one, for example. Okay, so on top of the 65200 that it's already learning, we're telling R1 that it's going to see a few more AS path of 65200. That'll force that'll force R1 not to prefer the R3 path. It'll prefer instead this alternate route. So let's go ahead and do that. Back to R3 here. So we'll say set AS path prepend 65200, 65200. All right, so now we need to get out of here, and then we go router BGP 65200. All right, address family IPv4, and then we say neighbor 10.10.13.1 because we are influencing our route advertisement to R1. We'll say neighbor R1 route map AS, where did I say AS path, right? Yeah, route map AS path right here. Route map AS path out. Why out? Because I'm advertising the AS path is going to take a few more ASs out to R1. Okay, so that's that. And now if I do a clear IP BGP star soft, let's go back to R1. So R1 previously thought that in order to get to any networks in 65200, it's simply going to go through the path of R1 to R3. R1 to R3. That's the preferred eBGP path. right? But we just influenced BGP route by saying that it's going to take a few more AS paths if you want to go through R3. So that'll force R1 to choose the link between R2 and R4. So here we go. We can take a look at the IBGP for R1. And now we can see that because we added a few more AS paths in here, the path to R3 from R1 is choosing to go through R2 and then R4, as you can see here, right? Even though it is an internal BGP path, we forced it to choose that route. Same for router 4 here. It's going through the R2 and R4, and then in order to get to R5's loopback 5.5.5, we are also indeed going through router 2 and router 4. Let's just compare that to before. Before it was going through R1 and R3, and so now it's going through R2 and R4. And so let's just verify with our trace route here, 5.5.5.5. So from R1, I just did a trace route to loopback 0 of R5, and clearly it's showing that it's going to go to R2, which is that, and then it's going to go through R4, and then it's going through R5. All right, and so that's how you do the AS path prepend route manipulation, and you do that on the eBGP router of R3 here, and you apply that route map in the out direction to R1. You're advertising that is going to take a longer path to R1 to get to the 65-200 networks. So let's go ahead and remove the route map. And then we'll remove that from the router BGP 65-200. And then we'll get rid of that also from the BGP configuration. There it is. And when we do that, I did a more of a reset than I needed to, but it's alright. It's coming up now, and we should see the routes come back to normal, and we should see which route is the best and valid path. Should come up here shortly. So AS path is back to just one AS path hop. Yep, one AS path hop, and we're just waiting for the routes to sync up here. And then the next thing I'm going to do is configure med. Alright, so that should come up. Alright, there it is. I was just waiting for two routes, two possible paths to show up to get to the destination network, which is what I want. Okay, so we are back to normal. So now let's take a look here. Let's take a look here. Again, so how do I get to networks in the AS65200? It seems like I am preferring the eBGP neighbor link here as my best path to get to anything in the AS65200, which is normal process because eBGP has a lesser administrative distance than IBGP. So, of course, it's going to want to choose the path of R3 to get to networks in the AS65200. If we take a look at the metric value, these are all 0 here. So the lower the metric is the more preferred path. So if they're all 0 and I want R1 to choose the path of R2 and R4 to get to networks in the AS65200, then I need to tell R3 to advertise to R1 that um, that some attribute is going to be configured for R1 to not prefer R3 as the next hop, and for the R1 to prefer R2 and R4 as the better route. So I could use med, since everything right now the metric is 0. If I advertise from R3 to R1 the metric value of 100 for this link, then R1 is going to not use R3. R1 will then prefer to use the path of R2 and R4 to get to the networks in these AS65200. So I'm going to configure R3 to advertise the metric value of 100 to R1. That will then make the metric higher. Therefore, R1 will not prefer this link, and it'll prefer this R2 to R4 instead. So let's go ahead and do that. We say config T. Again, we're going to use a route map. We'll call it med. And then set metric is what we want. Value of, say, let's just use 500 in this situation here. 500 is the metric value that we want because right now it's 0, but we want this link between R1 and R3 to be the less preferred eBGP path. Then we'll say 500. All right, so then now I can go and configure my BGP routing protocol. 65200 address family IPv4, and then I'll say neighbor. I'm advertising my new metric of 500 to R1. Neighbor 10.10.13.1, and I will say route map med out. Okay, I'm advertising the metric value out to R1. All right, so here was R1 before the configuration. R1 is learning loopbacks of R3, loopbacks of R4, and loopback of R5 through its best eBGP neighbor of R3. That was before the metric is configured. So now if I refresh and I hit the up arrow key, show IP BGP, what do we get now? So now the table has turned, and indeed we can say that we are learning the route to networks in the AS65200 through the R2 and R4 link right here. From R1, it's learning 3.3.3.3, that's the loopback on R3, through R2 and R4 right here, right? Because it also knows that there is a path there to that from R3, but since the metric was set to 500, the best and valid path is through the eBGP link of R2 and R4. And the same thing here for these two, and the same thing here for R5, right? So that's how you can influence traffic using MED. MED is the lower the MED value, the more preferred. The higher the MED value, the less preferred. So since this is 500, it's going to prefer this one. Since this is 500, it's going to prefer this route instead. And we can go ahead and do a trace 5.5.5.5, and we can see that indeed it is using 10.100.12.2, which is this guy, and then 10.10.24.4, which is this guy, and then it gets to the R5's loopback address. So there you go. That's how you can use MED to influence traffic for your BGP routes.